And now we're going to go to Joost Damaris, the CTO of KNX Association. He's going to be talking about together, KNX and IoT can build a better technical future. Joost, welcome today.
A good day also from my side. My name is Joost Damaris. I'm CTO here at KNX Association, and I'm going to inform you a little bit about KNX IoT and how it extends the development possibilities for existing and potential KNX members. I will first introduce the Internet of Things. So the Internet of Things is supposed to be one common communication platform. Then we are going to look at how the IoT world is standardized today. It's standardization of languages on top of IP. And we are going to ask ourselves the question, does IoT solve everything KNX solves today? And the next obvious question is then, what's the main difference between KNX and IoT? The next question that I want to put in the room is, could today's KNX still be improved? So there are already quite some solutions where KNX uses IP for communication, but are they still modern, and was there not a need to modernize them? Then we are going to look first at the third-party IoT interface, which is one part of the KNX IoT project. We are going to look at the aspect of semantics, which plays a role for the third-party API, but it also plays a role for the KNX Point API. This is another part of the KNX IoT project. And we are going to look at the overall KNX IoT project, its current status, and the further roadmap that still needs to be done, or the work that is still in the pipeline. And I will round off with showing you an overview of the different development possibilities that members now have, KNX Classic, as well as KNX IoT. Okay, let's get started. The Internet of Things. So this is a world where not only PCs and laptops and printers, etc., are being connected, but everything is being connected by communication networks like the current 4G and the upcoming 5G. So if we compare that a little bit to our KNX world, KNX is also, well, since its very beginning, it combines products of different manufacturers. It connects everything in a communication network, having different communication channels like wireless or wired. So if this IoT takes shape, then and everything moves towards IP, then one can ask oneself the question, are we going to simply do away with the need for twisted pair or for radio frequency, the KNX flavor of that? So is the dawn of the IoT the death of KNX? That is what question, the question which we should answer ourselves. If one looks at the standardization activities in the field of IoT, there are quite a bit of standardization activities going on. I can refer, for instance, to the Open Connectivity Foundation, or short OCF, an initiative involving, for instance, Intel. You have the initiative around Matter protocol, a protocol which has been announced as a common protocol for home and building control, well, especially home control, which is now being hosted by the former Zigbee organization, now called CSA. You have the thread group involved in providing wireless networks, especially for so-called constrained devices. And you have the Google being, for instance, involved in such activities as Weave. You have W3C and, for instance, the 1M2M initiative, which is especially driven by telecommunication companies. So many others are apparently thinking of using IP and standardizing what is being communicated on these networks. So these solutions especially want to already use protocols that are already in place, like HTTP and CoAP. If these initiatives use IP as a common communication layer, and they also use largely standardized communication or application layer protocols. So the question is then, where does KNX at all come in to this story? So to be able to answer this question, we should maybe first look at what is the difference between the current IoT and the available products there, and the way KNX solves the exercise. If you look at the IoT world, we look at devices that are mostly handled by different apps. So you buy yourself a fancy thermostat, you've got a separate app for that. You buy yourself a smart smoke detector, you have a separate app for that. And most devices, they simply serve one single purpose. So the smoke detector is there to detect smoke, and that's it. It cannot be linked to your smart door lock to say, in the case of a fire being detected, that this smoke detector would also make sure that the door is properly unlocked so that you have an escape route. And if you want to integrate all these products, then this integration is largely done not in the products themselves, but in the cloud. So you have a high dependency on cloud and the internet. If the cloud is not available, the link between the different products is simply not there anymore. And also, there's a high dependency on gateways. So if you have a gateway between product A and product B, of course, if the gateway fails, there is also no possibility to communicate between A and B. So your installation becomes a bit of a patchwork, and it is also very difficult to maintain such installations. And if there is a possibility to integrate product A with product B, then this is very much linked to the original supplier. So if the original supplier does not offer you integration possibilities with a product B you bought, then you are simply stuck. Also, you face a lot of regular software updates. So the question is, so your installation works today, but will it work also tomorrow when you run the next software update of product A or product B? So if we look at all these risks of the current Internet of Things, then one can fairly say that KNX has already more than 30 years of experience in solving all these issues, because from the very start, we have put a lot of emphasis in, for instance, that all products or of all different manufacturers really can be fitted into a coherent network, and they are interoperable to each other. When comparing KNX to the IoT, one also compares a world that is focused on the electrical installer and sells its products through wholesalers, compared to IoT, where the end customer walks into a DIY shop and gets his product directly from the shelf, or he does not walk into the store, he simply buys the product on internet and gets it delivered home. KNX has a 30 years track record of ensuring that an integrator puts together the desired functions of the customer into a coherent, smart infrastructure. So your home or your building. And very important, the building owner, so the homeowner or the building owner, is really the owner of the data and also of the products. And if you want to interface to KNX, you interface to an entire system, where in IoT, you largely, until today, you largely interface to several or multiple products. And also very important, in the IoT world, the building owner is not strictly the owner of his own data. This is quite a different to KNX. So yeah, I highlighted this in bold. KNX has a B2B focus, where the IoT currently has a B2C focus, not a business to business, but a business to consumer focus. In my eyes, as KNX, we really need to underline this difference, because otherwise people have false expectations in the products they buy. In my introduction, I said if we look at KNX today, does KNX not have any drawbacks whatsoever, especially when looking at the possibility of integrating products into already existing communication networks? We do have a wireless communication possibility, which is radio frequency solution making use of the 868 megahertz frequency. But the problem is this 868 megahertz frequency is not usable in every single country on this planet. In some countries, this frequency is not allowed. So if you look at wireless solutions, then there is one common frequency which is used a lot for smart home products. That is the 2.44 gigahertz frequency, which is an universal usable frequency. So it would be good if KNX would also offer the possibility to transmit KNX telegrams across a 2.4 gigahertz frequency. Then manufacturers could develop one single product and sell that in the different markets worldwide. If we look at KNX Twisted Pair, we have 30 years where we have proven that this is an extremely reliable and robust solution, and it's very easy to install. But for some product types, I have put some product types here in the slide. For instance, if you look at a washing machine, or you look at a charging station, or you look at a battery, or even a boiler controller, then these products would typically, if they would be communicating, then mostly they will be communicating directly via IP, not via twisted pair. So consequently, because of the necessity today to link such products twisted pair, KNX misses out on being used in many of such applications, because these manufacturers are reluctant to make use of the twisted pair network for communication. So KNX needs to do better than that. KNX twisted pair and radio frequency can continue to exist. They are ideal for some of the markets, but we need more media that allow communicating KNX across IP networks as well. Okay, if we look at standard KNX, so KNX Classic, as I have already mentioned, the products of different manufacturers can perfectly work together because we impose stringent requirements onto the product. So they first have to comply to the protocol requirements, including the configuration methods. And also they have to also comply to applicative requirements. So a dimmer must send messages where the data is encoded according to the KNX specifications. You cannot solve the exercise differently, otherwise you cannot brand the product with the KNX trademark. How the products are linked together is also standardized. Either it's standardized to make sure that the products can be configured with the ETS, the one common tool, or the products are designed so that the installer can make use of the so-called E-mode or easy mode. So to link the products by means of plug, touch, and play. By having these stringent requirements, there was a possibility to link this coherent system by means of a common solution to IP, I would say. And this solution is a widespread and long-standing solution. It's called KNX Net IP. However, if you look at the KNX Net IP solution, then you will see, if you technically look at it, that what is done there is the messages which are transported in a wireless network or a wireless KNX network or a twisted pair network. These messages are included one-to-one in an IP frame. So it means that the KNX specifics is also transported across the IP network. And here we have a difficulty because on IP networks, the receiver, typically an IT guy, when he gets this KNX message, then this KNX message does not include any information on where this message comes from. Does it come from the kitchen? Does it come from the office of the CEO? Does it come from the bathroom? This information is simply not conveyed in this message. And also the data that is transported in the telegram does not include information on what kind of application is transporting information here. Is it a light? Is it a temperature sensor? Is it a boiler controller? We simply don't know because this information is hidden in the ETS project. So this information, when the installer links products together by means of the so-called group addresses, he will indeed know this is a switching command, but when this is being transported onto the twisted pair bus or the radio frequency bus, and also when being transported onto IP via KNX Net IP, this information is simply lost. It's buried inside an ETS project. And this ETS project, okay, you can export this project, but this export format changes with every single new ETS version. So you can actually not really rely on this information if you would like to find this information about the location the information is sent from and whether what kind of application is sending data. So we needed a solution that actually abstracts this whole KNX specific information and provides a interface where one uses not the KNX telegram, but in where the message is transported to the one interested in this information by means of HTTP commands. And we also needed a new ETS export format to be able to convey the information about the semantics, so the meaning of the data, of the applicative data, also to this receiver. On the so-called third-party API interface, we transport the data with IT protocols, and we use IT security mechanisms. And also we include the semantics. So we provide a solution to the receiver in which all of this information is included. So the receiver no longer has to drill into the KNX specifications or the normal ETS project export to find this semantic information. One could easily say that this is a bit adding interoperability on interoperability. So inside the KNX network, the interoperability remains. But if transporting this information to the external world, we also create a sort of interoperability. I must point out that for KNX Net IP, there are a lot of solutions out there, but all of that is not standardized, and it does not include these advantages which are now being put into the IoT third-party API. Some words maybe on this semantics. What is this semantics all about? If you're as a human being, we are trained to understand concepts, and we also understand the relation between these concepts by nature. So, for instance, if I tell you, here is my son, then you immediately know that I am the father and this boy is my son. Machines cannot understand these kind of concepts, and they cannot understand these relations unless you help them to understand these concepts and these relations. And for doing that, one makes use of so-called ontologies. Ontologies make machines understand concepts of KNX installation, because that's what we want to do. And in technical jargon, such concepts in ontologies are called classes. Classes can also have subclasses. And the relations between these different concepts are called properties. So, or when you look at an ETS installation or an ETS project, this is actually an instantiation of an ontology blueprint. If we want to add more information to the data, so that data can be more easily interpreted by machines, then we need to add so-called tags to this information. If you look at KNX, at a working KNX installation, then information that is exchanged between products is done via so-called group objects. In the KNX ontology, they are called points. But if we want to give meaning to the data that is sent by these points, we need to make use of tags. What we could have done is we could have created a large amount of tags. But if these tags are put on a pile, then machines have a harder time of actually understanding the different types of tags. And that's why we have created tag categories, so subclasses, to make sure that the machine can easier find the information. Some of these tags we have designed ourselves. Some of these tags we have derived from other ontologies, like, for instance, QUDT and, for instance, Haystack. So how will this semantic information actually end up on this so-called third-party API interface? If you would have this interface, how will this data be end up on this API? Well, the KNX manufacturer will be able to add these tags to the product data. He will be able to upload this and provide this additional information, this additional semantic information, as part of his online catalog data. Of course, as an installer, you will continue to use ETS. You will simply download the product data, which will include this semantic data as well. And by having this specific export format for these third-party API interfaces, this semantic data will be exported as part of that file. So it will end up into this server. And the client speaking to the server will be able to also see this semantic data and see these additional tags that is provided across this API. Okay, now we have looked at the third-party API, but there is another project part in the large KNX IoT project that's called the Point API. And now I want to make you visible where this third-party API and where this Point API is actually located from a point of view in the entire system. So if one looks at a KNX installation today, consisting of twisted pair products, radio frequency products, and also KNX Net IP products, this is also possible. So if you have a IP network with KNX Net IP, today, if you use this solution tunneling the KNX frame on top of UDP, you can commission already today such products with the ETS. And there are also already various system stacks commercially available for that. But now we have added with the third-party API, we have added another possibility to link non-KNX products to a KNX installation. So via this red portion in this gateway or interface, one could link, for instance, a Sonos device to a KNX installation. So as I have just explained, the third-party API is an API at installation level. It's especially intended for devices that are not constrained. Not constrained means they have a lot of memory and they are connected to the power. They are permanently connected to that. On this interface, we provide the KNX data and the semantics via a RESTful standardized API. As security, we use TLS, and for authentication, we use or we impose even OAuth 2. The semantic export is provided in ETS on the basis of our own created ontology. And I must underline, there is already a software proof of concept freely available for interested manufacturers. You can find this proof of concept on the web page schema.knx.org. But we also want, I told you in the beginning, we also want to be able to use other IP networks like a thread network or even a Wi-Fi network for ensuring communication of KNX data, but not making use of an own protocol like KNX Net IP, but making use of common application layer protocols like CoAP or even HTTP. A difference between this third-party API and this Point API is the fact that here you do a connection at point level, not at installation level. Here we are looking at native IP communication. 4 constrained devices. And the data and the semantics is part of the data that is being exchanged between those different products. The security will use IT security mechanisms, so it will be different from KNX Secure, which is being used here. The commissioning by ETS is in preparation. It's not yet supported, but it is being developed as we speak. And also very important, here we have a software proof of concept, but here we even offer a open source stack, which will be freely available for anybody interested. Here I have included a slide in which the roadmap is included of the different parts of the KNX IoT project. So on the information model, so the ontology, the third-party API, and the point API. I can gladly inform you that the point API and the third-party API is already available as an approved standard. At the end of April, we publish the version 3 of the KNX standard. The third-party API and the point API specifications will be included as an approved standard. We are currently also working on, of course, being able to certify such products. We already have an approved test specification. We are now looking at extending the EITT tool, the test tool, with a possibility to also test such third-party API service. For the point API, we are looking at how we can support such products in ETS. And also for the third-party API, we will need this support of this semantic export also in a future version of the ETS. So to round off my presentation, a small overview of the different development possibilities now with KNX Classic and as well with KNX third-party API and point API. So if this is the twisted pair bus, of course, you can continue to develop products based on twisted pair lower layer chips. You can design your own stack, or you can license a stack, and you can design your own application for such a twisted pair product. This possibility remains possible in spite of KNX IoT. The same applies for radio frequency, KNX radio frequency classic products, same procedure. Of course, if you want to communicate between a twisted pair product and a radio frequency product, you need a media coupler. So you need a possibility to translate twisted pair to radio frequency and back. And you also need to design a stack for that. But now with the third-party API, there is the possibility to build a KNX third-party API server, so a different software, which sits on top of a intelligence able to communicate with classic twisted pair installations, and also the possibility via the third-party API to communicate the data of an installation also to a client, and this could be also a cloud service, of course. And on top of that, with the point API comes the possibility to look at other wireless communication protocols other than KNX radio frequency, for instance, to look at thread and design, of course, a different stack, use different chips, and also design your application on top of that. And of course, if you want to communicate to KNX Classic, you again need a gateway that has this way of communicating KNX. It combines this way of communicating KNX with this way of communicating with KNX. The intention is that all of these products can be configured by one single tool, where, of course, you could also make use of ETS apps if you want to extend the configuration possibilities of ETS with your own configuration possibilities. That completes my presentation. If you require more information on the KNX IoT project, then you can address myself or my colleague, Mr. Henel, our system and tool manager. Thank you very much.
Thanks, Joost. What an exciting time for KNX and for everyone involved in looking at the opportunities in Internet of Things. Would you mind just, can you address those current difficulties of IoT again? I just want to make sure I understand it properly.
Yes, the current IoT landscape is not yet what we expect from KNX. So the current IoT landscape does not yet provide you with a fully integrated solution. So a KNX customer is accustomed to, if he has an installation, that this installation, when it has different applications, that it is one coherent set of things. So that the that functions that are maybe belong to a specific application could also exchange data to other applications. In my presentation, I've made the example of a smoke detector. So a smoke detector, of course, the essence of a smoke detector is that you are warned when there is a fire. That is evident. But this could, for instance, also help the homeowners to escape from their home more easily by, for instance, if there is a fire, that the lighting towards the or on the escape route is shown by your smart home. And you could think of a million other things you could realize thanks to combining the data of the different applications.
I think that's one of the interesting things about IoT is how it plays with other technologies. And that leads me to ask about the impact of 5G for IoT. How do you think that affects the opportunities for KNX IoT?
Yes, I think, of course, 5G comes with a promise that there will be more bandwidth available. So more bandwidth means you can transport much more data. And it comes also with a promise that you can link more devices to the internet. So if you look at what 5G can offer compared to, for instance, 4G, that is a factor of times 10. So with 5G, the promise is that you could link up 1 million devices per square kilometer. So that is a vast amount of things you can connect to the internet. So there is talk of being able to connect as many as 50 billion devices to the internet. This is, of course, a huge amount of devices. But I'm pretty sure that within the home, that I still expect a lot of devices to still be connected to communication ways that we already know today, like, for instance, Wi-Fi or Thread. I do not necessarily think that all devices will be directly connected to 5G. I could think of some appliances, for instance, being connected to 5G, or maybe larger size devices in your home that are connected to 5G, but mostly these devices will still use communication means that do the job today like Wi-Fi.
Yeah, so 5G doesn't come free either, so it's something that you might not want to have everything connected to all the time, or at least the telecom providers might like it. But
Indeed. That's why I think I do not see the 5G penetrating into the home and to every single thing you have in your home. But it opens up also new possibilities. That is true.
yeah, of course. One last question, because you highlighted the need for the current improvement for KNX to meet the IoT challenge, but I see from the roadmap that you're addressing these improvements, and this has been underway for some time, and we'll see the results this year in most cases. So along the way, KNX has had a history of innovations and been successful with it, but what is the time frame between acknowledging an issue and when it can be adopted?
Yes. Yeah. Sometimes it is. Well, some people might feel it a little bit frustrating that, of course, it's not possible with the snap of a finger to realize a certain improvement to KNX just like that. Of course, because of the fact that KNX is an association, it is a community of manufacturers making use of a common infrastructure. There is a need for extensive discussions between different manufacturers. And of course, the offer must be adjusted to the needs of these different manufacturers. It is, of course, of no use that KNX designs something where the manufacturers shrug their shoulders and say, this seems a nice thing, but it's not actually the technology we were looking for. So that's why we need a extensive debate with our manufacturers on the features of a system. This was the case for KNX Secure. This also took a number of years to really materialize in the market. And the same thing is with KNX IoT. And also KNX IoT, a lot of manufacturers have, for instance, KNX Net IP solutions in the market, which are perfectly working. So these are perfectly working solutions. It also takes some time. It takes some time for manufacturers to, of course, uh, 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 complement this offer by the new technology possibilities that are offered by KNX or have been designed by KNX. It's a natural process, I would say.
Yes, it's a natural process, and certainly one that's proved successful over the years for you. Joost, thank you very much. Thank you for helping us through how the KNX and IoT together can make a better technical future. Thank you for joining us today.
You're welcome. Thank you very much. Bye to everybody.